Okay, this is going to be short. This is just a quick example playing with couples. So what I have here is a bizarre contraption. So it's just a right angle beam for whatever reason. And so this is point B here in this beam. And so if we look at the beam, we go up 2 feet, and then at an angle of 30 degrees, we have 40 pounds. Go up 4 feet, we have a force of 40 pounds, also at an angle of 30 degrees. So if you compare these two, all right, they're equal, opposite, parallel, and not collinear. So these two combine to be a couple. Now if you go up 1 more foot, so 7 foot total in the air, you get to point B, and we make now a right-hand turn at Albuquerque, as it were. So you go over 3 feet, and we have a 60-pound force that's applied at an angle of 3 to 4. So that's telling us a whole bunch of information about sines, cosines, and all of that. This is a 3, 4, 5 triangle. We use them a lot because they're just easy to use. And then we go over 4 feet. Now we have a 4, 3 triangle such that these are equal, opposite, parallel, but not collinear, 60 pounds. So these two correspond to a couple. All right? And so the question is, what is the moment at B? You can do this 2 basic ways. We can just look and say, okay, this force exerts a torque at B, this one exerts a torque at B, this one exerts a torque at B, or this, and that one exerts a torque at B, and add them all up, which would be a pain in the butt. Or you could go, oh, this is a couple, and if I compute the couple anywhere that's convenient to me, that torque that the couple produces is the same everywhere on this device. Likewise here, I could compute the couple I could compute the couple moment at one spot that's convenient, and the same is true at B. So then I could just add up the 2 couples together and be done. All right? So that's just easier for us to handle. So let's just take a look at this. So here I have, these are at 30 degrees coming off, 40 pounds, 30 degrees up. Here's 40 pounds, 30 degrees down. If I was to put a line here and create that perpendicular distance here, all right, so this distance straight along here would be 4 cosine 30. That would be that perpendicular distance between them, 4 cosine 30, and we have 40 pounds. So 4 times 4 cosine 30, that perpendicular distance, which is right there, bam, that is this couple torque. Looking at it, yep, it's going counterclockwise, 138.56. So no matter where you go along this thing, that you have the same, this whole rigid body wants to turn the same way. Now we have this one. Now if I look at this thing, it's going like so, all right? And so if I see what's happening here, that one looks like it's trying to go clockwise in my mind. And let's see, where do we have this one? Minus 192. Okay, here we go. So we have 60 pounds, and all I need to do is, so what I'm going to do, so we have 60 pounds. Let's just look at this distance across here. All right, so if I take, for this, the vertical component would be 60 times 4/5. That would be the amount of the force going straight down. All right, the amount of the force going out this way, that aligns with this point. I'm going to compute the moment right here. Okay, so the x component of the force does no moment, only the y component of this. So 60 times 4/5 times 4 feet, the distance here. And then if I take the torque right here, this force is going through that point, so it exerts no torque. All that I have is minus 60 times 4/5, the y component, times 4 foot for the distance is minus 192 foot-pounds. So here I have 138.56 positive, minus 192. So this is kind of neat. We have a torque kind of happening over here, but the whole body would have to be responding to this thing. And basically that means there's more for the supports down here to fight. Okay, so we have a clockwise torque here, a counterclockwise torque here, and they just add together. So we have 138 minus 192 leaves us with minus 53.44 pound-foot or foot-pounds would be the effect of the torque at B. Now, I will note that in my notes in 1 year and for my class, I actually said, well, let's check this. And so here's all of these torques applied at B. And if you go through the math, you indeed get minus 53.44 doing it the long way. This is a lot easier. All right, we have one more concept we need to do in this chapter. I'll be starting that shortly.